Hello, welcome to an Algebra 2 quick review of lines. Okay, so today we're going to review writing the equation of lines and also graphing lines. Okay, so remember the slope of the line is just the rise over the run. So it's going to, if you have 2 points, x1, y1, and x2, y2, it's just going to be the difference between the y's. So y2 minus y1 gives us the rise over the difference between the x's. x2 minus x1 gives us the run. So we end up with 4 different types of lines if we classify them by their slopes. A line with a positive slope goes up to the right. A line with a negative slope goes down to the right. For zero slope, this is one of our 2 special cases, zero slope and undefined slope. Zero slope is horizontal lines, goes with horizontal lines, and horizontal lines has 2 O's that would look like zeros in their description. An undefined slope goes with a vertical line. The parent function for all linear functions is the most basic linear function, which is y equals x. For y equals x, it has a y-intercept of 0, 0. It goes through the origin. And then it has a slope of positive 1. So we go up 1 to the right 1, up 1 to the right 1 to get other points on the line. Recall that the y-intercept of a line is the point at which the line crosses the y-axis. It's where it intercepts the y-axis, so it's the y-intercept. The x-intercept, likewise, is the point where the line crosses the x-axis. In this special case, 0, 0 is both the y-intercept and the x-intercept. Okay, so we're going to graph an equation in slope-intercept form. We know it's in slope-intercept form because it's in y equals m, so slope x plus b, the interesting value of the y-intercept. And so we know that the y-intercept is going to be 0, 1, because our value for b is 1, and our slope is negative 3/2. So the first thing you want to do when you go to graph this is you need a starting point. So you're going to start at the point 0, 1, and then from the starting point you can apply the slope. So negative 3/2, we can go from our starting point of 0, 1, we can go down 3 and right 2. Or we could take the negative and apply it to the denominator and go up 3 and left 2. So either way, that's going to give us a point on the line. Okay, so what if a line is in standard form and we want to graph it? It's not in y equals mx plus b form. One way we can do that is to find the x-intercept and the y-intercept and plot the 2 points and then play connect the dots. So to find the x-intercept, we're going to let y equal 0. So the x will be interesting for an x-intercept, the y will be 0. So we take our original equation, 2x plus 3y equals 12, and we substitute 0 for y. And so that leaves us with 2x plus 0 equals 12. So 2x equals 12, so x equals 6. So we have the point 6, 0, and we would plot that point on our x-axis, and then we move on to finding the y-intercept. For the y-intercept, you're going to let x equal 0, so you're going to take that same original equation and substitute in 0 for x, so you'll have 2 times 0 plus 3 times y equals 12. Well, 2 times 0 is just 0, so if I have 3y equals 12, I divide both sides by 3, and I get y equals 4. So then I get the y-intercept is 0, 4, so I would plot that. Let's see, 1, 2, 3, 4, 0, 4. I would plot that on my y-axis. And once I have 6, 0 and 0, 4 on my graph, I just connect the dots, draw a line through it. Notice that there's arrows on the ends to indicate that the line keeps going on forever. And I have my graph of my line. Okay, horizontal lines and vertical lines are our 2 special cases. Remember, horizontal lines have a slope of 0. They are going to be written in the form y equals c, and they go through the point 0, c. Vertical lines, remember, those have undefined slopes, and they're going to have an equation of x equals c, and they're going to go through the point c, 0. So if I have y equals negative 1, I go to the y-axis, I find negative 1, and then I draw the horizontal line through negative 1. Okay, so it's the horizontal line through 0, negative 1. I want to graph x equals 2, I just come over here to the x-axis and find 2, plot that point, and then draw the vertical line through it. So we end up with a vertical line through the point 2, 0. All right, writing an equation of a line, our end goal is going to be the slope-intercept form y equals mx plus b. Oftentimes, however, we're either given the slope or we can determine the slope, and we're given at least one other point, but it's not the y-intercept. So we start off with point-slope form that works for any point on the line, which is y minus y1 equals m times x minus x1. Once we have the equation in this form, we apply our algebra rules and we transform it to slope-intercept form. There is that third point, the third form, standard form, ax plus by equals c. Remember, when we have an equation in this form, there's no fractions, and a is positive. If you are given 2 points on the line, then first use the slope formula to find m, then use point-slope form to write the equation of the line. So whenever you're determining whether or not you have a final answer, you need to look and see if it's in y equals mx plus b form, slope-intercept form. If not, you need to transform it till it is in that form. So we're going to write an equation of a line with the slope of -3/2 and y-intercept of 0, 1. So we're given the slope and the y-intercept, so we can go straight to a y-intercept form, y equals mx plus b, and just plug in what we know. So y equals -3/2 x plus 1. On the next problem, we're going to write an equation of the line that passes through 2, 1 and has a slope of 2. Okay, so we've got the slope, we know m. We're given a point. Because the x value is not 0, we know this is not the y-intercept. It's just a general point on the line. So we're going to use 2, 1 as x1, y1, and we're going to start with point-slope form. So we're going to let x1, y1 equal 2, 1, and m equal 2. And so we're going to use point-slope form, y minus y1 equals m times x minus x1. We're going to plug in what we know. So we're going to plug in 1 for y1, 2 for m, and this 2 for x1. After that, we're going to use the distributive property to simplify the right-hand side. So y minus 1 equals 2x minus 4. And then we're going to transform this to slope-intercept form by adding 1 to both sides of the equation. So we get y equals 2x minus 3. Okay, we know this is in slope-intercept form because we've got a constant times x and then plus or minus another constant. Okay. Now, we're going to write an equation of the line through 3, 1 and to -3. Now, from geometry, you know 2 points define a line. So we know this is enough information to give us everything we need to know to identify this specific line. Now, one thing that's different about this problem and the prior examples is we're not given the slope. We're actually going to have to calculate the slope. So first, we're going to use x1, y1 is 3, 1, and x2, y2, we're going to use 2, -3, and we're going to use our formula for slope, y2 minus y1 over x2 minus x1. So we're going to have -3 minus 1 over 2 minus 3. So that gives us -4 over -1, which divides out to be 4. So we have a slope of 4. Now, we're going to plug in m equals 4, because that's what we just determined, and let's just leave x1, y1 is 3, 1. You could use 2, -3, but we've already said x1, y1 is 3, 1, so let's just go with that. We're going to plug those into point-slope form. So we're going to have y minus 1 equals 4 times x minus 3. Okay, so let's transform it. We're going to distribute that 4 to get y minus 1 equals 4x minus 12. We add 1 to both sides to get y equals 4x minus 11. Okay, so now it is time for you to do some practice on your own. So go ahead and do the problems in your problem set. Please come see me if you have any questions at all. Thank you. Have a good day.